Now in part A here, we want to know what is the limit as x approaches 210. Now what's going on here? It says the monthly charge in dollars for x kilowatt electricity hours used by some residential customer, somebody's house, in a particular city is given by this function. So it looks like this is the cost over here. So if they use how many hours? Somewhere between 0 and 210 hours, their cost is going to be like 5 cents times the number of hours. If they use between and including 210 to 340 hours, their cost would increase, right, to 8 cents times the number of hours. And then if they use 340 to 450 hours, their cost would be 10 cents times the number of hours minus 6.8, and then same thing for 450, substituted in here. As we approach 210 hours, so let's approach first of all from the left. So if we come in from the left, we're going to use this cost function. So that's going to give us 0.05. Now we're approaching 210, so I'm going to put the 210 in here and see what I get. So I got 10.50. So as we approach from the left, we're approaching $10.50. Now as we approach from the right, we're going to be in here. So we come in from the right, so we're going to be approaching 210 from above, so we're going to use this part of the function right here. So that's going to give us 0.08 times the 210. And 0.08 times 210, do it on your calculator if you like. When I do it, I got 16.80. So as we come in from the left, if we're below 210 hours, we're approaching 1050. As we come in from the right, if we're just a little bit over 210, it jumps up to 1680. So there's a big jump here. These are not equal. So we're going to say that the limit as x approaches 210 of c of x does not exist. For parts B and C, we're going to do exactly the same thing. We're going to come in from the left, we're going to come in from the right, and you will see, you can try this now, these are not going to exist just as part A doesn't exist. In part B, we want to know what is the limit as x approaches 340 of c of x. Well, as you come in from the left now, all right, here's 340. Come in from the left. We're just a little bit below 340, so we're using this function right here. So it's going to be 0.08 times, let's put in the 340. So we're going to get 0.08 times the 340. And that gives us 27.20. All right, so as we're approaching 340 hours, our cost is going to be 8 cents an hour. So it's going to be approaching $27.20. That is, we're a little bit over. If we just get over 340, then where are we? We're a little bit over, so we're using this function right here. That's going to be 0.1x minus 6.8. So we're going to put in 0.1 times the 340 minus 6.8. Well, and that turns out to be, when I put in this, I get 27.20 again. So it looks like the limit from the left and the limit from the right, these are equal. So that surprised me. I thought they were going to be unequal, but they're not. So as x approaches 340 of c of x, that limit is 27.20. In part C, we're going to look to see what the limit is as we approach 450. So let's do it up here. So we're looking for this. We want to know what is the limit as x approaches 450 hours of that cost. Now, as we come in from the left, if we're below 450 hours, we're right in here. So we're going to be using this part of the function. So we're going to write 0.1x minus 6.8, and at 450, this is going to give us 0.1 times 450 minus 6.8, and I think we just did that one, right? We did that one right down here, so that's 27.20. So this becomes $27.20. And as we come in from the right, we're just a little over 450 hours. So we'll put the 450 into this part of the function here. So we're going to have 0.12x minus 15.8. That'll give us 0.12 times that 450 minus $15.80. And on my calculator, that comes out to be 38.20. Now, since the lower, coming in from the lower part and the upper part are not equal, we're going to say that this limit, as x approaches 450 hours of that cost function, does not exist.